Welcome to part 2, which is 2 in French, of dilations, similarities, and slope. So we're going to continue looking at similarities. Which pair of triangles are similar? So remember we talked about the sides either need to increase or decrease, all 3 sides or 4 sides depending on the shape, all need to increase the same number or decrease by multiplication or division only. So we're going to look here at this first one. I have a half, and 12 inches. So let's compare. Let's start with the first one here and compare it to the second one. Can I multiply a half to get to 13? No, not at all. I can't even do that. So these two are not similar at all. So let's check the 13 by 13 by 16 compared to the 1, 1, and 24. Well, I can divide 13 by 13 to get 1 on each of these sides, but 16 divided by 13 is not going to give me 24. So I know that that's not a possibility. So let's compare 13, 13, 16 to 5, 2, and 6. Well, right off the bat, I already know that 5, 2, and 6 are not even going to be an option. The reason why is you can see all these other triangles, they have the 2 sides all of the same number. So that means I know that I need to increase or decrease by a certain number. I can't have 2 sides of this example, of this triangle, be different. So now let's compare, since the 13, 13, 16, and 1, 1, 24 are not the same, and neither 1/2, or 12 are the same for any of these, we know that the middle triangle is not going to be an option either because of the same thing. We already just double checked that we can't go from 1/2 to 13 or 12 to 16, and we could do 13 to 1, but 16 to 24 is not possible. So let's double check and make sure. From a half to 1 is times, let me change the size of the pen, is times a half, right? Or if you wanted to go the other way, half of 1 would be half. So what if I multiply 12 times a half, it will give me 24. Or vice versa, if you do it the other way. I know that 1 to get to a half would be to divide by 2. So I would have to divide 24 by 12 and get that. So our 2 options are, these are our 2 similar triangles. Now I'm going to switch it up on you, and we're going to look again at quadrilaterals. So again, we're looking for the similar one to the one above. So I want you to pause your video, take a second, go through the process that we just did with the other ones, crossing them out, noticing a pattern, noticing which side is which, those kinds of things. So take a minute or so, pause the video, and see if you can figure it out. Now that you've paused the video and have calculated it, let's see if you're right. And I do encourage you to pause the video and test yourself. Even if you get it wrong, that's totally fine. And sometimes your brain clicks and goes, oh, duh, I had to multiply, not divide. But anyway, we're looking at an 8 here, a 6, and a 6 for my sides. So obviously, all these shapes are different shapes, which is totally fine. It could be upside down, it could be sideways, it could be, anything like that. But let's see. Did you notice right here that this angle has 2 sides? 2 little swivels or circles, indicating that that is my second angle, and that it's similar to something else? Well, let's see. This side right here is 6. This side is 6. Okay. This side is 8. All right. So if I look here, I only have one little angle. So I have one little angle here, if it was the same. This is not going to be one of our options, because it's not increasing, it's not decreasing, it's not even changing. It's not even similar, honestly. There's no other set of missing angles there. So let's try B. All right, let's see. I have all of the same angles. Here, here, here. Let me erase this up here. I have all of the same angle amounts here, here, here. They all indicate that they're all the same. So that tells me that from here to here should be similar from here to here. Well, 8 to 4. How can I get from 8 to 4? Divide by 2, right? So 8 divided by 2 would give me 4. But let's double check the other sides, because sometimes it might not be right. If I divide this by 2, I do get 3, and same thing here. Perfect. So B is going to be our option and our answer. Now you could look at these and you could say, okay, even if you didn't know anything about the angles, obviously from 3 to 8, that's not even possible, and the 6's did not change. And, yeah. I'm not even going to talk about D. It's pretty clear that it's not the same shape. Well, if you tilted it is, but as you can see, if this was the top, it would be 6 to 8, which doesn't compare. So now that we've reviewed about similarities and dilation, let's move on to slope. So slope, everybody's favorite thing in the world, right? Well, let's review real quick. What is slope? Well, slope is the change in y over the change in x. How much my y amounts are changing versus my x amounts. So remember, rise over run. Up means it's going to be a positive number. Down means it's going to be negative. Left means I'm going to be positive. Right means I'm going to be negative. So our slope formula, remember the y2 minus y1 over x2 minus x1? This is where it comes into play. So remember, this is all the same thing. Look, the change in my y's over my change in my x's. One way that you can remember is that the word u starts with y, r over, which means division, your x, which x is on the bottom. So y is always on top, x is always on bottom. Another thing to remember is the slope-intercept form. That is our y equals mx plus b, where these are the m is my slope, b is my y-intercept, where it hits the y-axis. That's why it's y-intercept, where it intercepts my y-axis. X is going to be where I put my input values, and y is going to be where I put my output values. So let's look at some examples and solve and jog your memory. So a lot of you guys had a lot of questions that involved words, tables, and check all that apply. So the cost of y of x packages of crayons at store A is represented by this equation. So my store A is represented by this equation right here. Y equals 0.50x is what store A offers. The packages of crayons at store B are shown in this table. So this is store B, and store A is over here. It doesn't have a table, it just has an equation. So it says, check all that apply. The packages of crayons package of crayons at store A cost more. Well, how can I figure that out? How do I know what the equation is for store B? Well, look, I can take my cost, which is y, so 3.25, and divide it by 5. I want you to pause the video and do that math. So when you divided it, you should have gotten 65 cents. So this is how much at store B is going to cost. So if I was going to write an equation, it would be y equals 0.65x, because that's how much each package of crayons is going to cost me. So let's see. The package of crayons at store A cost more. Well, 50 cents versus 65 cents? I think not. Store B is going to cost more. So then my next one says the cost per package at store B is 65 cents. That is 100% true. So what you're going to do is on the question, you're going to check in that box. The packages at both stores cost the same. Is that true? Absolutely not. We just found that it was 65 cents for store B and 50 cents for store A. Those are not the same numbers. 25 packages at store B would cost $16.25. So how can I actually solve that? Well, since I have my equation, and X is the number of crayons and Y is the cost, I can plug in Y equals 0.65 times, it says 25. So what I want you to do is plug that in and multiply. What you should have got is actually 625, which is 100% true. So what you needed to do is check that one too. And let's check the last one. The packages of crayons at store A cost less. Is that true? Absolutely. Store A only cost 50 cents versus 65 cents for packages of crayons. So anytime you have questions like this, use your process of elimination. Figure out what each of the equations are would be my biggest suggestion, and then compare them. So now I'm going to find the rate of change from this table. So remember, rate of change is just another word for slope. All right, just another word. So I can actually find the change in Y over the change in X. So it's changing from 40 to 30 is how much? -10. It's decreasing by -10. And from -38 to a -23, that's going to be +15. And if I take 23 to a -8, that is also going to be a +15 because we're getting closer to 0. So remember the change in Y, that's what this sign means, over the change in X. So my Y is going to be -10 over my +15. Now, the real question is, can I reduce this? Absolutely. They both can go into 5. So my actual answer is going to be negative divided by a positive is a negative. 10 divided by 5 is 2. 15 divided by 5 is 3. So this is my slope, my rate of change, -2 over 3. So now that we've actually practiced problems from a table, some words, now we're going to look at graphs. So remember, in order to figure out if it's what's the slope, you can look at the graphs. First thing I notice that this is a negative line because it's decreasing down, and this is a positive. You don't have to label that it's positive or negative for your own benefit, but if it helps you figure it out, perfect. So I know my answer is going to be negative. Let's look at the first graph here. I'm going to find clear points that I can see, meaning I need to choose 2 points that I can see that are exact. So like -2, 3 is clearly on my line. I can clearly see at -2, I go up to 3, and boom, there's a dot. My other one is going to be -1, 0. So remember, slope is rise over run. So in order to start here, I would go down 1, 2, 3. So it's going to be negative and over 1. So my slope for this one is -3 over 1, or just -3. Sorry guys, we're going to have to come back for a part 3, unfortunately, but don't worry, you've got this.